Thanks, Brian, and the committee. So I'm here to talk about the status of the task group that was put together several years ago. Here are all the cast of characters. Everybody played a key role in putting together a document that we have distributed to the Lake Committee that basically outlines the rationale, prospects, and recommendations for action for rehabilitating native forage fishes in Lake Michigan. It's a draft now. We still have some work to do, but we've made quite a bit of progress. Let's see. Okay, so here's the task group was established in 2013, and we were asked to scope out the feasibility of restoring native planktivores. When I'm talking about native planktivores, it would be the Corrigonian complex that we've seen several talks about in the last couple of days, and identify opportunities for promoting restoration, and then develop this white paper of recommendations. So here's the most of the fish that we're talking about. The ones that are X'd out are ones that are now considered globally extinct. We're going to basically limit our discussion to Xenithicus, Kii, and Nigripanus, but also include Artidi, the lake herring, or the Cisco, unfortunately, as it's now being called. And we do touch on emerald shiner as well, but I'm not going to talk much about emerald shiner in this talk. So, reasons for the declines. We all have heard this the last couple days: overfishing, effects of exotics, habitat degradation, all worked in concert to basically destroy this, one of the most diverse complexes of Ciscos in the world, which were not only present in Lake Michigan, but across all the Great Lakes. Similar diversity in Lake Huron, lesser so in the other lakes. So opportunities now for reintroduction exist. We've got alewife and biomass low. We need an alternative forage. Commercial fishery that was implicated in some of the declines is certainly much smaller and well controlled now. We do have source populations of Artidi, Kii, Nigripanus, and Xenithicus. They exist. They exist in other Great Lakes and small inland lakes, like in Ontario and Nipigon, in varying degrees of densities, but they do exist, and they do provide an opportunity for gamete sources, either most likely to build captive brood stocks, like what's being done with Corrigonus hoyi in Lake Ontario. That project, which is, if you guys were here a couple days ago, is going quite well. There's about 3 or 4 year classes of broodstock established in the Ontario Ministry hatcheries. It is being done, and we're learning lots with the egg take procedures and the rearing procedures. We've made a couple of forays to Finland, taken 2 groups over in the last 3 years, and basically have looked at their hatchery capabilities for raising Corrigonians, and they've been doing this for about 20 years now. So a lot of that technology is easily transferable over to North America for these. And then we got a situation where, although we have lower productivity in all the lakes, we think that zooplankton communities and maybe even mysis communities may be adequate to support Corrigonian introductions. So this increasing oligotrophication in Lake Michigan, we've heard about this in the last couple of days, characterized by declines in phosphorus, increasing spring-soluble silicon concentrations, water transparency is going up, this lack of a characterized diatom plume, loss of cladocerans, and in particular, the increased importance of limnicallinus, and the unfortunate decreases in diaporia in offshore waters. Now, the historic Corrigonian complex, a lot of these animals relied on mysis and diaporia. However, these trophic conditions now resemble that of Lake Superior, as we heard Dave Warner refer to, and Lake Superior does and is able to sustain its native complex of Coregonines. So even though things look dire, the fact that we have situations similar to Lake Superior suggests that there is some opportunity. So here's from Barbiero's paper showing the convergence of the zooplankton community. Basically, the last observations in that paper are in the mid-2000s, but as you can see, Limna calenus is now, which is predominant in Lake Superior, is now predominant in Lake Huron and Lake Michigan as well. And that just happens to be what Cisco like to eat. So even though we have this decline in productivity, you have a species complex that could certainly support Cisco. And as we've seen from other presentations, the decline in alewife and rainbow smelt. I mean, that's one good thing, is basically opening up a spatial niche. It was always thought that these animals were basically in the same spatial and trophic niche as the Coregonine complex that disappeared. But this is a paper from Stephanie Schmidt's dissertation, PhD dissertation, where she looked at stable isotope biplots, where if you look at the carbon becomes enriched as you go inshore. This axis is referring to stable isotope of nitrogen. The further you go up, the higher in the trophic level you are. So basically, if you look through these time series that she analyzed from museum specimens to more contemporary populations, even though, so here's the original fish community with all the deep water Coregonines and Cisco. Rainbow smelt was in there a little bit. So even though they were kind of on a similar trophic position, rainbow smelt and alewife were certainly in more near shore and certainly never occupied the same trophic and spatial space as these deep water Ciscos. And this niche remains empty and has remained empty since the decline of these animals, which creates another suggestion for an opportunity. Now the situation for mysis and certainly Diapraia is pretty bleak, but a lot of these animals were not Diapraia strictly dependent. They fed on a composition of mysis and Diapraia. This is a paper from Chuck that was put together by Chuck Mendengian. It's in review, showing mysis densities across a number of years, showing that even though mysis densities have declined, there still may be enough residual there to support deep water introductions. So we talk about the residual Coregonids that we have now. We have small populations. This is work from Randy Claremont, Michigan DNR. And well, basically, this is at the commercial and recreational harvest, which is fairly low and non-existent, but certainly showing an increase in Cisco over the last couple of years. Bloater, as we've seen from failed recruitment events, has been declining over time. This is commercial harvest of bloater, showing that it's actually fairly low, and if you actually divide the harvest over the standing stock biomass, depending on which time series you're looking at, the simple exploitation is showing that the fishery is really not having any impact. We're looking at less than 0.4% of taking of the standing stock. So we can't really implicate fishing as a probable cause for at least low bloater numbers. And this is a comparison of Cisco numbers across, just to put into context what Lake Michigan looked like in terms of Huron and Superior. So it's nice to see that we do have still residual Ciscos, but they're certainly dwarfed by the other lakes. So strategies for recovery. There's only so many things you can do. One, you can protect your remnant stocks. Seems like that's going to help us with bloater because we're hardly harvesting them anyway. and Cisco. But the thing is if you do nothing to these, you're likely not going to get the rate of recovery that you're actually looking for. You can attempt to improve habitat to promote remnant stocks. This has been suggested for Cisco, but that's not going to have the lake-wide capacity. And certainly this animal is not as, it doesn't have that many habitat requirements, although there was a variety of life history, spawning life histories and habitat occupations. The most predominant form of Cisco, RTD, basically they need water and each other. There's really not a lot of other physical habitat requirements. So, which leaves you to reintroduction of extirpated species. And we've spent a lot of time talking about that. The ecological objective is to provide a forage to piscivores that reestablishes those vertical and horizontal energy transfers across depths and trophic levels. That's something that was their ecological function, and we're hoping to restore that by replacing those animals. Now you can say, well, did smelt and alewife do that? They did that to some extent, but if you've read Jason Stockwell's recent paper showing that the transfer of eggs from offshore areas to nearshore areas provides an energy subsidy. Those eggs sat on the bottom for 6 months and feeding benthivores and providing lots of energy. That's quite a bit different than alewife and smelt coming into shore in the spring and those eggs remaining there for a matter of weeks. So the short-term and long-term objectives provide self-sustaining shallow and deep water native forage-based that will use the existing invertebrate resources, and certainly longer-term would be to provide fisheries on populations that have surplus production. So this is a table in the report where we actually scope out for each species the rehabilitation options, source populations if that's being under consideration, the pros and cons, the information needs, the relative probability of success, and when I say timeline, that's likely when it could begin. So here, this is focusing on our TD. We figure protective remnant stocks, and we look at all the characteristics associated with that. I'm not going to read these off, but certainly we're considering source populations both within Lake Michigan, the few that are there, in connected or unconnected lakes to Lake Michigan, certainly a possibility, and looking outside Lake Michigan to Superior and Huron. Habitat restoration was considered, but like I said, that's probably not going to get us where we want to go. So it's likely this is going to provide us the most bang if we want to extend our TD outside areas where we have remnant populations. Looking at short jaw, blackfin, and kai, probably of these three, kai, as we heard from Dave Warner, they're certainly very abundant in Lake Superior and deep water. Lots of them. The pros is that it would help diversify, provide genetic and ecological diversity. Logistics would be our challenge. We think, based on Keltz's work, that they would be available in late fall, early winter, before ice up. So they would be possibly available, but we need to look at time and place of spawning and so on. We think they have a medium to high success. Short jaw Cisco, fairly low densities virtually everywhere they are found, although in Lake Superior it's been suggested that there may be a possibility for an egg source there. Blackfin Cisco reside in Lake Nipigon and newly discovered populations in Algonquin Provincial Park. Not much is known about them. This is one of the largest of the Ciscos. Very interesting finding here. Hopefully over the next several years we'll find out more about the accessibility of gametes there. certainly, you know, we do have the probability that remnant stocks there may be too low to support any restoration. But certainly, if we were looking at a continuum of probability of success, highest being with Cisco, lowest being with short jaw and blackfin, this is how we would put it. These distances are just, they have no value other than just their relative position. So we do have some questions regarding our TD source populations. Within the group, there was a lot of discussion about the pros and cons of remaining in Lake Michigan versus going outside. What we want to do is, a lot of these revolve around the remnant populations that are in Lake Michigan. How unique are they? And what's the possibility of disrupting that genetic uniqueness if you bring something else in? So what we've done is put together a series of questions relating to, with the aim of basically discovering which populations would serve as the best donors, okay, for any restoration initiative. And what we want to do is put together a team of geneticists and task them with these questions. So on genetic diversity, effective population size, genetic differentiation, I'm not going to read these all off, but you get the idea of where we're going with this. Last one, what would be the best donor populations and what would be as secondary sources if the best donor populations, let's say, aren't available because of logistics or low or inability to support a gamete program. So best donor populations we characterize are the ones with highest genetic diversity. Animals from the same habitat type present no disease risks, are large enough to support routine gamete collections, and are logistically feasible. We don't want to be going out in the middle of Lake Superior in February because we couldn't get there anyway. So, I mean, so this is the kind of stuff that we're considering, and it's not just the genetics, it's all these other things that we have to consider for donor population issues. So that's all I have. I'd be happy to answer any questions. Thanks.